Okay, here's some sample problems, both using the triangle proportionality theorem and the triangle mid-segment theorem. Okay? And again, I apologize if I cough or hesitate because of scratchy throat. It's pretty simple. We've got one here that shows we have two parallel lines, and we've got these segments. Well, if these are parallel lines, we know that it is dividing these two segments into proportional pieces. This one's pretty straightforward. 5 is to 5 is 7 is to x. Any doubt about what 7 is going to be? X is going to be? It's just simply going to be 7. 5x equals 35. Can we do it another way? Yes. 5 is to 7 as 5 is to x. Any doubt about what the x is going to be? No. We can simply look at that and tell that what that's going to be. Okay, let's look at this one. We have parallel lines, therefore we know that these are proportional with each other. Here's one way to set it up. 9 is to 18 as x is to 20. Then that becomes 180 equals 18x, x equals 10. Or we could say 18 is to 20 as 9 is to x. Same thing, we're coming up with 18x equals 180, x equals 10. Okay? It doesn't matter how we set that proportion up, as long as we set it up correctly, then we're going to get the same answer. Okay? Here's one a little more challenging. We've got some unknowns over here. Excuse me. Again, we have a triangle as parallel segments. Meets the requirements of the triangle proportionality theorem. We have x and 11, and then we have this whole thing is 33. Well, if this part is 11, what's this part? It's 22. So what we've done is we've calculated that part, and we've made that. Okay, now we have x, and we have x plus 12. So let's set up our proportion. X is to 11, x is to 11, as x plus 12 is to 22. X plus 12 is to 22. Now, you can probably look at this and determine what it's going to be. Okay? This is 1/2 of this. This is twice this. This means this is going to be 1/2 of this. This is going to be twice this. That means x is going to be 12. Let's make sure. When we cross multiply this, we get 22x equals, multiply both parts, 11x plus 132. We're going to subtract the 11x from both sides. We end up with 11x equals 132. Divide 132 by 11, and we get x equals 12. Okay? So over here, x equals 12. X plus 12 is going to equal 24. Okay, look at that carefully and make sure you understand what we're doing there. Now we're going to look at a mid-segment. Pardon me. Triangle mid-segment theorem. Triangle mid-segment theorem. Okay? Here we're given a triangle. We're told that these two are parallel. We don't necessarily need to know that. What we're interested in order to find out what's going on, is the relationship of this segment to the other sides. We know this is equal to this, this is equal to this. Therefore, this point has to be, this point right here, has to be the midpoint of this side. Same thing over here. It has to be the midpoint of this side. Why? Because this part is congruent to this part. Okay? So we know that this meets the requirements of the triangle mid-segment theorem. Okay? So we know that this piece that is parallel to this side, because it's a mid-segment, is going to be 1/2 of the side it's parallel to. If this is 35, then we know x is going to be 1/2 of that. X is simply 17. Pardon me, 17 1/2. Okay? So there's 4 problems. 3 of them dealing with the triangle proportionality theorem. 1 of them dealing with the triangle mid-segment theorem. Okay? Let's do about 3 or 4 more, and we'll be through with this piece of it. Okay, now we've got 4 more problems we're going to do on this parallel lines and proportional parts. Okay? So let's look at them. Here's one here. We've got parallel lines. These vertical lines are parallel, and we've got proportional parts. How in the world are we going to look at this? Well, set it up right here. 3x is to 5x, 3x is to 5x, as 12 is to x plus 12. Okay, so let's look at this one really close. 3x is to 5x is 12 is to x plus 12. So 5x times 12 is 60x equals 3x times x is 3x squared. 3x times 12 is 36x, so plus. Now, let's rearrange this and combining like terms, put them all on one side. 3x squared minus 24x equals 0. So we take 60x, subtract it from 36x, we get a negative 24x. Now, doing a little bit of algebra manipulation, we can remove or distribute out 3x. When we do that, we're left with x minus 8. Well, how do we solve a quadratic equation? We set each one of the factors equal to 0. When we set this factor equal to 0, then x equals 0. Does that make sense for us? No, because we need something that has length to it, and x equals 0 doesn't work. So we set this factor equal to 0, x minus 8 equals 0, x is going to equal 8. Okay? So when we plug it back in, 5 times 8 equals 40. 3 times 8 equals 24. 8 plus 12 equals 20 to 12. So 12 is to 20 as 24 is to 40. Okay? All right? Look that one over. Pretty nice little problem to do. This one down here, we got 3 parallel lines. The horizontal lines are parallel. We have proportional parts. 5 is to 8 as y is to y plus 2. So we're going to set that up. 5 is to 8 as y is to y plus 2. Cross multiply. 8y equals 5 times y plus 5 times 2. So 8y equals 5y plus 10. Combine our y's. Subtract 5y. 3y equals 10. Y equals 3.3333 repeating. When we put those over here, we get 3.3 repeating equals y. And y plus 2 equals 5.33333. If you'll put those in here, you'll see that that is the same proportion. 5/8 is the same as 3.3 repeating. 3 1/3 is to 5 1/3. Okay? Look at those problems. Make sure you understand the algebra we set up. Now this one looks sort of hard, is really very simple. We're given 3 parallel lines in this triangle. We're given that those parallel lines break this piece up into 3 congruent pieces. That means all 3 are congruent. Well, what do we know about these 3 pieces? If these 3 are congruent, then these 3 have to be congruent. So therefore, each one of these has to equal 12. We don't even have to know what this is over here. So we can set these 2 equal to 12. 12 equals 2x minus 6. It also equals x plus 3. Let's take one of those and solve for x. 12 equals x plus 3. Subtract 3 from both sides. X equals 9. Plug it in. 18 minus 6 equals 12. 9 plus 3 equals 12. That's what we would expect, okay? Sometimes this makes it really simple. We can design our proportional parts so that they're congruent. It makes the calculations pretty simple. Let's look at our last one here. Have this figure. We have 3 horizontal lines that are parallel. They cut this segment into congruent pieces. How do we know? because of these marks right here. These two are congruent. If they're congruent, how do we solve for x? We set them equal to each other. When we set them equal to each other and solve for x, we get that x equals 5. Plugging it in, 2x, 2 times 5 is 10, plus 4 is 14, 3x is 15, minus 1 is 14. So they're equal. Well, if these two are equal, what do we know about these two segments? They also have to be equal. So how do we solve for y? Simply set those two equal to each other. 3y equals 2y plus 2. Okay? Just look at that and you're pretty sure y is going to come out to be 2. But let's do it. Subtract 2y, y equals 2. Plug it in. 3 times 2 is 6. 2 times 2 is 4, plus 2 is 6. Proves our point. That's parallel lines and proportional parts. Okay? Study the problems. Fairly simple. You get confused on them. It can become very, very complicated. But study these sample problems.